So, I think I'm gonna look to review some of the bits that I've been studying about modern physics. The first one is about time dilation. This one is about time dilation. Basically, what time dilation means is a phenomenon in which time in a moving frame of reference feels slower than when viewed by the other not moving observer. Basically, that is time dilation. So the way it works is, of course, we have the formula. We have the formula for time dilation. We have the formula itself is just t equals t0, or is it t null? Let's just call it t0. T0 divided by the square root of 1 minus b squared divided by c squared. This is the formula for time dilation. But question is, how do we actually get this formula? Okay, that is what we're going to do today. Is this formula, how do we derive this formula from the known facts and basic math that we have studied? So for this one, consider a flashlight. Maybe this thing is a flashlight, yeah, and this thing is a mirror. And when the flashlight is turned on, so light just emanates from this thing, and we take the time for the light to go to the mirror and then back as t0. And then we have the distance of the mirror and the lamp as L0. So if we have a light with velocity c, this is the speed of light, by the way, c, we'll have an equation such as like this. We know that the velocity is distance divided by time, right? So let's just change that up a bit. So the velocity would be the speed of light, and then the distance would be L0, and then the time would be from here to here. Notice that the time itself is T0 divided by 2. Remember that when it hits the mirror and then going back into the flashlight, the time is T0. So half of that, which is when the light reaches the mirror, would be T0 divided by 2. So the T itself would be T0 divided by 2. So we're going to have the equation for LO equals 2C divided by T0. Wait, no, it's not like this. TO divided by 2. Okay, so TO divided by 2 times C. There you go. This should be good. And yeah, equals L0. This is the correct one. Okay, so what next? Well, we'd have to imagine another scenario. Picture another flashlight. This is another flashlight, but this time the flashlight is moving, like in that way, with velocity v, or maybe speed v. And like just imagine that this is a jet-powered car or something. I don't know. So basically, the flashlight is moving, and right here, we'll have a mirror again. This is a mirror, and then so this will be set up so when the flashlight is turned on, the light itself would travel along with the moving flashlight. So the light would go sort of like this. It would go sort of like this, the light. And from here to here, we should take the time that it'll take to reach that place as t. Yeah. Or maybe to simplify things, let's just take that as t over 2. T over 2, right? Since t would be just the time from the flashlight to go there and then going back. So the time to actually half of that, which is just from the flashlight to the mirror, would be t over 2, as opposed to returning back, which is t. Okay, so we have another LO right over here, the distance from the flashlight to the mirror, and then we'll have sort of like this thing right over here, the distance thing. If you notice, this thing would be just a right triangle, right? It's a right triangle. This one is denoted by LO, and yeah, let's just call it LO, yeah? And the distance of this one would be just V times T over 2, right? So basically what happens is from here to here would be T over 2 because it reaches the mirror. When it reaches the mirror, the flashlight would be traveling along this distance right over here. So we would get V times T over 2 for the distance along the movement of the flashlight. And this one itself is the travel of the light. So we use the speed of light and then the time it takes to get there, which is T over 2. Right, using the Pythagorean theorem, we would have the equation ct over 2 squared equals LO squared plus VT over 2 squared. But remember that we know what LO is. LO is just this thing, right? LO is just CTO divided by 2. So let's just substitute that. So this is CT over 2 squared equals V. Oh wait, not V, it's C. C T0 divided by 2 squared plus VT divided by 2 squared. Alright, let's just do some basic algebra. We'll have something like C squared T squared divided by 4. Remember, it's squared. And then this would be C squared TO squared divided by 4 plus V squared T squared divided by 4. Notice that we have 4 in both sides, so we can just cancel them out. And then we'll be left with C squared T squared equals C squared TO squared plus V squared plus V squared times T squared. So how about we group the T squared together? It would be sort of like this. C squared divided by V squared. No, not divided, subtracted by V squared. And then we'll have the T squared right outside. Or maybe to just make things easier for you guys, we just take it one step at a time. Minus V squared T squared equals C squared TO squared. Okay, we can group C and V together. So C squared minus V squared, and then T squared would be just outside, equals C squared TO squared, right? Okay, let's move the left-hand term, the C squared minus V squared, to the right-hand side. So it'll be like this. Divided by C squared minus V squared. Now look, this C squared right over here, we can just move it right here, right? So it'll be something like this. C squared minus V squared divided by C squared. If we do a modification of that in just a sec, we'll have C squared divided by C squared, that's 1. And then V squared divided by C2 would be just the thing right over there. Okay, so let's rewrite the last equation we've done. So we got TO squared divided by 1 minus V squared divided by C squared. So we'll get this equation. T equals TO. Remember, we just take the roots of both sides, and the root of TO squared, which is TO, and then the square root of the denominator would be just the square root of 1 minus V squared minus C squared. That's it. So just a heads up, the T is the time in as observed, would be the time as observed, and the TO would be real time. This is for the moving party, for the moving I don't know, thing, I guess. Moving thing. And then v squared would be the velocity of movement. So yeah, and c would be the speed of light. And that's it. We got the time dilation, which states that the time, what is it, the time that is observed by an observer that is standing still would feel slower than the time that the moving person is feeling while they are moving nearing the speed of light. That doesn't make any sense, but I'll improve. Yeah, I know how messed up that explanation just sounds like. Maybe there's some mistakes in that, but yeah, I'm gonna improve on that in just a bit. For the time being, let's just wrap this up for now.